second, okay? Here, we'll do an example of that. It's a little weird, I know, but it's important. Now, so this is what we do. Basically, the area to the left of Z, you're going to subtract that from 1. And the area to the left of Z, that is the percentage of data values that is less than a data value. That's less than something. So essentially what we're doing is we're taking what's in the table that we saw and subtracting it from 1. That's really what it boils down to. So for instance, remember that example with the weights of the dog breed? We saw that the weights of that certain dog breed, it turns out that they're normally distributed with a mean of 62 pounds and a standard deviation of 6 pounds. Now, we already know how to get the percentage. Now, I don't know if we found this actually, let me say this, but let's find the percentage now of dogs of this breed that weigh more than 55 pounds. So we are going to look for the percentage of data values bigger than 55 pounds. Okay, well, let's first get the Z value. I know, we can use Desmos, but the Z values is something you should know how to work with. So with the Z value for 55, again, it's just like before, right? Subtract off the mean, divide by the standard deviation, right? Subtract the mean, divide by the standard deviation. We get negative 7/6, which is about negative 1.17. So that's the Z score for 55 pounds in this problem. Okay, so now what do we do? Well, if we went to the table, let me get back to the table. See if I can share it again. So we had negative 1.17, but notice again, that's not in here, right? Negative 1.7 is not in the table. So what do? We round. We're going to round to negative 1.2. And that's what we're doing. We're rounding, okay? We're rounding to negative 1.2. Because again, negative 1.17 is not here. But by rounding, we get 0.1151. So we're rounding to negative 1.2, and we get 0.1151. Okay, well, we're not quite done yet. Let me get to this. Here we go. So I wrote down above what we saw, but this is the area to the left of the Z score. Okay, that's the area to the left is 0.1151. We want the area to the right. Well, what do? Well, we subtracted from 1. So if we subtract that from 1, that gives us the area to the right of negative 1.2. We subtracted from 1. Again, the total area is 1. We subtract negative we subtract off 0.1151. And what's left over is the 0.8849. So that's the area to the right. That tells us the percentage of data values is 88.49%. You know, about that. You know, we did approximate a bit, but that's what we get. So again, we got the entry from the table. That's area to the left. We subtracted from 1, and we're left with the area to the right. That's what we did. Okay. Any questions on that? Okay. Here's another one actually. Let's now, this is from the data from before with the test scores. The test scores are out of 10, okay? The scores are normally distributed. There's a mean of 6 and a standard deviation of 0.3. So this is from before, the data values. Now let's find what percentage of students scored greater than 6.5. What percentage of students scored greater than 6.5? So it's just like before, right? We're going to use z-scores. First, we get the z-score that corresponds to 6.5, right? We know that the mean is 6, standard deviation is 0.3. So the z-score for 6.5, that's this thing. And we saw that this is not in the table, so we had to round it to 1.7. So this is the z-score for 6.5. We rounded this to 1.7 because this is not in the table. And if you looked in the table, I think we actually saw this, that the area to the left of 1.7 is 0.9554. But that's to the left, though. I don't know why this is here. That should not be here, that part. We don't want the area to the left. We want the area to the right. So to the right, we subtract, and we get this, 0.0446. And so that tells us the percentage is 4.46% about. That's what we get here. Okay, that's what we get here. Okay, that's good. Okay, this one is one I was going to have you guys try, but I think we're kind of getting low on time. So I want to do this with you guys, but I'll be right back. Okay. So here it's a little bit similar. We want to know what percentage of students scored greater than 6. Here the data, okay, it's test scores. They're normally distributed. It's out of 10. The mean here is 5. And the standard deviation is 0.5. Oh, no. Okay. So it's just like before, right? We have to figure out, though, what the z-score is. Okay. Well, since the mean is 5 and the standard deviation is 0.5, right? The percentage, and we want the percentage of scores greater than 6. Okay, so for 6, we find the z-score that corresponds to 6, right? That's what this is here. We have 6 minus 5 over a half. We get 2. Okay. Okay, so now if you looked at the table and looked for 2, it's there actually. You would get the area of 0.9773. But again, that's the area to the left. We said here greater than 6. And we get the area to the left is 0.9773. So how do you get the area to the right? You subtract it from 1. That's what we're doing here. Subtract it from 1. And we get this. Okay, you can see, so we get 0.0, 227. So the percentage of students that scored greater than 6, it's about 2.27%. That's what we get. All right. Now, I was going to do this. I'll start from here next time, okay? Basically, how would you get the area between two z values? You are basically going to subtract. That's what's going to happen. Where one z-score is less than another. So let's say z1 and z2 are the z-scores. z1, let's say, is smaller than z2. And let's say you want to know the percentage of data values between z1 and z2. You would get that from the table, you would get the area to the left of z2 and subtract the area to the left of z1. That's what I'm trying to show with these graphs. And hopefully you can see that. I mean, we'll go more into this next time though. So I think we're gonna have to stop here because we have like a minute left. And this is actually